guys, this is Vortek, and today we're going to continue our player character movement tutorial series, talking about how we can transition our character from a walk to a run, and also introduce a strafe mechanic that allows us to have a little bit more finer control over our fighting stance. This is going to come handy when we expand our character and have some target locking. So, let's get started. Alright guys, so let's get started. And we're going to begin by looking at our player character header file, and we're going to introduce a handful of new properties as well as a couple of functions that will allow our animation montages just to be a little bit more intelligent about processing our strafing, running, and walking. So, to begin, let's find our getters for our various properties, and we're going to add a few more just around here for handling our moving forward, moving backwards, right, left, as well as whether or not we're running. So I'm going to, actually, you know what, we're going to copy and paste this, and we're going to add a new boolean for is running, and ideally is rushing, that's not right, is running. And ideally you always have sort of method accessors for your properties, just to eliminate any sort of potential hacking if you have multiplayer games. If your properties are already, available, you're not pushing them through methods, you kind of lose that fine level control of server-side validation. So just bear that in mind. And we're going to add now a couple of additional getters for our move right parameter, as well as another one for our move forward. And these are going to be the two guys that drive our strafing blend space. So our move right parameters are going to be +1 or -1, same for move forward, and based on that we can determine which animations to play. Cool. So in addition to that, we're going to expand our functionality for our arming of the player by adding in another method called armPlayer immediately, for lack of a better descriptor. And what this method is going to do is it's going to call armPlayer from a key press, and we're going to modify the armPlayer function to take in a boolean that basically flips it from is it armed or is it unarmed, and that will give it just a little bit more flexibility for when we control the state of the player arming. So that's that. We're also going to add another couple of functions to determine whether or not we're running. So this is, again, to tie into our key binding. So when we press a certain button, in this case it's going to be shift, we can start running. And we can also end our run. So with these methods in place, we now have a little bit more accessibility into our player character, but we're not done just yet. We now need to add in a couple of properties that are going to be referenced by those functions. So I'm just going to copy and paste this uProperty header, and I'm going to introduce a new float for max crouch speed. And this will allow us to, through the blueprint of our player character, control the speed of our crouch movement. And we're going to do the exact same thing for max walk speed, as well as max run speed. And because we want even finer level control over our movement variables, we're also going to add max arm speed. So this is the speed of the character when we are in our arm position. So with that in place, we can start moving forward, but just before we get too far, we also need to add a couple of private properties that our getters are going to actually access. So we're going to add a new boolean for b is running, float for move forward value, and another float for move right value. Okay, great. So now let's flip over to our CPP file and keep implementing these methods. Okay, so in our CPP file, we're just going to kind of go down the list and start cleaning up some of our old definitions. Because we are working from a previous project, there's a couple of properties that we need to actually remove. And one of them is right here, orient rotation to movement. So what we want to do is by default turn this off. So it's actually up to our game to control whether or not we rotate the player to the movement or not, because we don't necessarily want it to be available in all cases, specifically when we have our strafe up and running. So we're going to get rid of that guy. And then we're going to go down, let's say somewhere around here, and we're going to fill in some of our properties that we just set up by adding in some default values. So our max crouch speed, we'll set it to 200. Our max walk speed is going to be 250. Our max run speed is going to be 600. And arm speed is going to be, let's go 200 as well. So the same as the crouch. Okay. And then what we want to do is we want to update our default movement speeds with some of these values. So we can call our get character movement component, on which we're going to set our max walk speed to be our max walk speed. And then we're going to do the same thing for our max walking speed crouched, and we're going to say max crouch speed. Okay, so this kind of defines our initial starting points. Oh, two other things I'm just going to clean up real quick is I'm going to get rid of the left and right collision boxes just so they don't keep appearing on the character's hands. I think we all know by now where those guys are located. So yeah, let's keep going down the list. And I'm just going to clean up some of these bits here. So I'm just going to remove a couple of extra comments from the tick. We don't necessarily need that. And then we get to our binding input parameters. You'll notice that our arm player is now a little bit busted because we added a parameter, right? It expects, oops, no, that's not dot overlay, it's not working. It expects a Boolean as the input. So that is why we created that other method, arm player immediately. No parameters. We can now tie it to our key press event. Cool. So let's go ahead and now start throwing in our additional inputs specifically for our run states. So if I go to our player input component, write action, we're going to say run. So it's going to be on pressed. We're going to pass ourselves in and our run start method. I'm just going to copy and paste that and switch it over to our release state. So when we let go of the button, and that's going to call run end. So excellent. We have these keys now bound to specific operations. Let's go ahead and keep moving forward. So, okay. So in our move forward definitions, we now need to fill in those move forward and move right values with something. So let's start with move forward. So our move forward value is just going to represent our value. And if you notice, we're really not doing too much logic within the movement side of things outside of basically handling the defaults, which is, hey, I'm rotating in a certain direction and I want to move in that direction forwards. If I want to move backwards, then it ends up rotating me around, and it's not going to align with our strafing that well. So let's go ahead and make this logic just a little bit more intelligent. So we're going to take this junk and we're going to say, if I'm armed and I'm not crouched, then fill in strafe logic. Otherwise, we can paste back in the stuff we had previously. So that's pretty straightforward. But what we also want to do is we want to handle our character rotation. So let's start breaking that out. So if get character movement, use controller desired rotation. So if we don't have that available to us, what we want to say is get character movement, use control desired rotation, and we're going to set that to true. And get character movement, orient rotation to movement, we're going to set that to false. So basically what we're doing here is this one little check is saying, hey, have I already set this value? So on subsequent key presses, I'm not going to execute this logic. And basically what I'm saying is, if I'm in my strafing mode, I want to rotate my character towards where the controller is pointing. But I don't want to orient his rotation towards the movement. So we want to actually move from side to side independent of where we're facing or our character is facing. So that's this little bit of logic here. And then lastly, what we're going to do is for strafing, we're simply going to say add movement input. Our direction is going to be the actor forward vector, and our value is going to be our move forward value. And what this will do versus the logic below is it's not going to handle any of the directional input. It's simply going to say, hey, am I moving forward? Or rather, get the forward position of the actor and then either move him forwards by passing in +1 or backwards, which is going to be -1F. And while we're not moving, it's 0. So this is going to handle our strafing logic. Now, for our regular sort of running around the level logic, we need to do something very similar. So we're going to say again, if get character movement, use controller desired rotation. So now if it's turned on, so it's the opposite of this state, we're just going to flip those values around. So we're going to set that guy to false, and we're going to set orient rotation movement to true. So there's our move forward setup all ready to go. Now move right. And as I'm sure you can imagine, it's going to be very, very similar. So I'm going to set the move right value to our value. We're going to say, hey, am I armed? And am I not crouched? Because we don't necessarily want to handle the same type of logic when we're crouched. And we're going to say else. And we're going to move this logic in here. And then again, we're simply going to say, we're going to grab this chunk here. Right? Because we want it to behave the exact same way. So if I'm just moving right, I also want to handle these control manipulation settings. And likewise for when we're moving in a regular mode, we want to flip them back. And then again, as I'm sure you can imagine, for our strafing, we're going to do the same thing we did with our forward vector, but we're going to get the actor's right vector. And we're going to move it by our value. So again, +1, -1. Let's just make a note of that. This is going to be left, right. Or is it vice versa? We'll find out. But either way, this is going to move it in the right orientation from the right vector of our player character. So that gets us our movement mechanics, but now we also need to introduce a bunch of those getters. So specifically, where do we put these guys? We're going to make modifications to these in just a second, but we're also going to implement these guys first. Now, You guys may also notice my color scheme is a little bit different, and that's because I flipped from Visual Assist to ReSharper, trying out the new 19.1 EAP. It works really well, super fast. Check this out. We can generate an implementation super quick. But if you don't have ReSharper, we're going to type all this stuff out by hand just so we get into the habit of doing these things from scratch. So there's our is running. We're also going to introduce our float. Nice build. So this is going to be our get move right. There it is. Let's get to return our move right value, and we're also going to do the same thing for our forward value. And there it is. All right. So there's our three getters. We're already handling the isArmed state. We're just not necessarily using it in all over the place. So that's good. Running is net new. Now let's go ahead and clean up our other methods. So our arm player, run start, run end, as well as this arm player immediately. So if we look for our arm player, you'll notice it's now complaining because we added a boolean as an input parameter. And the way this guy is going to work is we're simply going to flip-flop, similar to the way we were handling with our single value, but now it's going to be user-driven, or rather, rest of the system-driven. So we're going to say value as our input, and now we want to handle this case of, okay, so I'm not armed. I have these countdown values for our timer manager, and we may leave this stuff in. We may get rid of it. I haven't decided yet. But we also need to check if I am running. So if I'm not armed, but I'm running, then do something. Otherwise, do something else. So in this case, what we're going to do, if we are running and we are not armed, then our character movement is going to be set to our max run speed. And what this allows us to do is kind of flip-flop between different movement settings. And obviously, if we're not running, then our max walk speed is going to be the max walk speed. Okay. And then if we are not armed, or sorry, if we are armed, then our character movement max walk speed is going to be set to arm speed. So as you can see, the way this is going to work is if I'm pressing something for my armed state, I go here. Otherwise, I can handle the situation of flipping from walking to running, and vice versa. Okay, so that gets taking care of this particular method. Now let's go ahead and add in our arm immediately. And what this guy is really going to do is he's simply going to turn on the arm player with a true value. So let's throw that up top. 2 live character player immediately. And what we're going to do here is we're going to say arm player true. Oh, sorry, not arm player true. B is armed. And I do apologize, that's my kitty making all kinds of noises. Let me just stop this for a second and shoo her out of the office. Sorry about that. She has a bad habit of breaking into the office while I'm trying to record. So, arm player immediately simply takes in our current arm state and flips it using the opposite Boolean sign. So cool. If it comes in as true, it's going to flip to false, false to true, etc. Now, let's go ahead and introduce our run methods. So we say run start, and let's throw in another one for run end. Okay, so the logic in run is pretty straightforward. What we want to do is we want to basically say, hey, do I have any other states sort of available to me? And if so, if I don't have other states available to me, then proceed with setting in the run. So in this case, hey, am I armed? And am I not crouched? So if none of these two states are true, then I can go ahead and say is running equals true, as well as set my movement speed to my max run speed. And we're going to do the same thing for run end, just to be certain that when we come out of these states, we're also handling our conditions correctly. So again, if I'm not running, if I'm not crouched, then B is running equals false, and when I get character movement, walk speed is going to be set back to our walk speed. Okay. Let's go ahead and recompile all of this, make sure I don't have any issues. And then let's move into our actual editor and start creating some of these blend spaces. Okay, so we're all recompiled, and now let's go ahead and start creating some of these blend space definitions that our movement components are going to use. So under the tutorial resource folder, animation section, I added in a couple of additional animations, specifically for strafing left, right, forwards, and backwards. So, let's move these into our locomotion folder. And we're going to create a new blend space. But before we begin, let's take a look at this existing blend space for our crouching. And you see it's only 2D. So what that means is we only have one axis to control. But in our case, we want to have a 3D blend space that allows us to basically have, not a 3D blend space, just a blend space that has 2 dimensions. And we're going to call this BS Strafe Locomotion. And you'll notice when we open up this guy, we have 2 axes now, a horizontal and a vertical. And the way we're going to organize this is we're going to have our animations for moving forwards and backwards on our horizontal axis. Sorry, our vertical axis, and our strafing left to right on our horizontal. So this is going to be our move right axis. This is going to be our move forward. We're going to set the maximum value, the minimum value to -1, and our maximum to +1. The number of grid divisions, it's okay to leave it at 4, but you can adjust it, based on your fine level control. And then we're going to do the same thing with the move forward. So -1, +1, 4 sections. And now if we go to our animation list here on the right hand side, we have our armed idle, which we're going to pop right in the center. So at 0, 0, so if I'm not moving forward or right, that's what my guy's going to look like. If I'm moving left, he's going to go this way. If I'm moving right, he's going to go this way. And what I'm doing here is I'm holding down Shift as well as the left mouse button and just kind of dragging around the position of our blend space. So there's our left shimmy, our right shimmy. We're going to have a forward and a backward. And again, in order to have some better animation definitions, you also want to have sort of move forward and right, move forward and left, move backwards and left, all those additional states in between. Otherwise, the system just tries to blend them as best as it can. But there's our forward, there's our backwards, and we'll have some kind of weird in-between states here that we can also correct a little bit by adding the same animations in those corners, but I'll let you guys experiment with that. So there's that. There's our new locomotion. Now let's take a look at our animation blueprint, because it has now a bunch of states in here that we no longer care about. So specifically, when we were experimenting with our armed mechanics, we kind of had these haphazard, slapped together layering sections that are no longer applicable, because we're basically going to go either in an armed state, an armed crouch state, crouch, or just, idle walk run. So let's take a brief second just to review these details, and we'll go ahead and start cleaning that up. So if we look at our idle run state, you'll notice we're doing a bunch of stuff. We're blending in our is armed or is moving with the player animation, and we're trying to get clever with stuff. No longer is that really necessary, because we're going to flip states as we move between our animations. So I'm just going to get rid of all of this for now. Make sure we just connect our third-person idle run. And this is the one that comes with the default project. It was already built in with a walk speed as well as a run speed. And these values you may want to adjust to, again, be more in line with the speeds you're kind of using. So in this case, we've got 375 as run. Our walking ends at about 93, or rather it's a full walk at 93, but then it kind of gets slower from there. So if we look at our player character and some of the definitions we just put in, you'll notice that our walk speed is 250, and our run speed is 600. So we might have to adjust that blend space just a little bit to get some slightly better definitions on there. But there's our player character definition. And going back to the animation blueprint, let's go ahead and now clean up the armed states. So we don't need this or this. We're going to get rid of those. And we're going to add a new state. This is going to be our armed locomotion. And let's add a line going back to it, to crouch state, as well as back from our crouch. So let's go ahead and now add in these states. So we want to move into this armed locomotion based on our is armed property. And this is going to be when is not armed. Now, in this state, this is going to be our strafing state. So to this, we're going to make reference to our strafe locomotion. But if I look for my move right or my move forward parameters, you'll notice they're missing. And the reason they're missing is we didn't actually add them to our player anim instance, which is the class that this animation blueprint inherits from. So let's go ahead and now add in those properties. So flipping back to Visual Studio, let's take a look at our player anim instance class. So let's start off with the header. We need to add another couple of properties. So I'm just copying and pasting the definition of our U property, and we're going to add one called is. B is running. We're also going to add a float for move right, and another float for move forward. Going back to the CPP file, right in our native update animation call, we're now going to bring in these three properties. So B is running equals our player character and is running, that lovely getter we just put in. And move forward is going to come off the player character as well. Move forward and move right. Move right. So let's recompile, and now these three properties should be available in our blueprint animation. Okay, so with everything recompiled, let's go back to our project. And now we have an accessor for our move forward as well as move right. So great, we've got these two parameters. And now, if we, for example, manipulate these values and we set our arm state, you'll see our little preview. You know, he's shimming around. So move right, -1, he goes the other way. Move forwards, move backwards. Stuff is happening. And there's our arm state. Okay, so let's keep taking a look at our definitions for this animation blueprint. So we have our arm locomotion states, both for crouch and sort of regular. Now this guy here is doing a bunch of additional logic just because we wanted some interesting blends to occur when he was crouch and we were using animation. So we're going to leave that as is. Our crouch locomotion is still okay. I don't think we really need to tweak anything here. So we'll leave that as is. And our states are all good. So let's compile this. Actually, let's come back. So to locomotion to armed, crouch, locomotion. Why is that? Oh, okay. Get us crouching. And what boolean? Get us crouching. Okay, so there's our cleaned up states. Hey, everything's happy. So if we load up our game now, you'll see when we throw the punch, he steps into our armed state. But that goes away pretty quickly. And then we move forward, we move to side to side, and as you can see, it's not working as expected. So our arm state, if we press R, he gently walks forward, back, side, side. So that part of it is working as expected, but then when we get out of our unarmed state, you may notice that by default he wasn't doing anything. And that was when the game started. So we have a couple of conditions we need to adjust where all of our logic starts kicking in when he actually gets armed. But there is our walking. You can see it's already kind of in a run mode because of those values in our blend space. So we're going to clean that up in just a second, but let me just take a quick look here what else is going on. And our running doesn't work. Now, our running doesn't work because we didn't actually do anything with our shift button. So let's go ahead and just clean that up one by one. So first things first, we're going to go into our project settings, and under input, we're going to find where we're already using the left shift, which is on the light attack modifier, and we're going to flip that actually to just left alt for now. And then we're going to add a new mapping for running. And it's going to be off our left shift button. So let's now test that out. So there's our walk. And if we hold down shift, you see he starts moving a little bit faster. Now, the animations don't look super good, but we'll clean that up in just a second. So there's our walk, and there's our run. Cool. Okay, so we have our running, walking. Now let's go ahead and clean up the blend space that's associated with it. So under Content Mannequin Animations, there's the default third-person idle run 2D. And this is where all I'm going to do is I'm just going to bump up that walk value to be a little bit higher up. So when we go to 200 for our walk, we're going to be somewhere around this area. So it's still a bit of a walk, but it's got a bit of kind of a briskness to it, and then we'll leave the run as is. Let's go ahead and test that out. So there's our guy, he's armed, let's get rid of that. And there he is running. And there he is walking. So much, much better. So we have our run, our walk, and then we have our arm state that handles the strafing. Now he's still moving quite fast, so we're going to adjust that a little bit. But the running and walking is actually not too bad. Again, we have all these values externalized through our blueprint, so let's go ahead and now mess around with them a bit. So under our player character, right here, what we're going to do is, we're going to set the arm speed to 100, so maybe half of what we currently had. Guy. See, much better. So it's a little bit closer to what we're hoping to get. Now, it's still a little too fast. And again, part of this is also the animations that I'm using. They're not exact. So you're going to have to mess around with some of these variables to kind of get them to exactly what you're looking for. But I'm going to slow them down by a little bit. The other thing we're going to do is we turned off those the visibility of our boxes, but because it was kind of blueprint driven, you'll notice it didn't quite take, but it is informing us that the default state is hidden in game. So I'm just going to turn those guys off for sake of experimentation. Okay, so there's our walk, there's our run, throw in our arm state, and that's actually much better. So our forwards, backwards. Okay, this is looking pretty good, but I don't like this. I don't like it how he flips from side to side immediately. Likewise with forwards, backwards. It's kind of jarring. We don't want that. So to correct that, we're going to go back to our animation. We're going to find our locomotion strafing blend space. And then on the left-hand side, what we have is target weight interpolation speed per second. And basically what this means is how quickly or how slowly do I blend between these different states. Now, because it's set to 0, it's immediate. So I'm going to bump it up to something quite fast, but it's going to create like a nice smooth effect between the animation changes. So let's get into arm state. And now, you see when I flip from side to side, he nicely rotates and handles the blending, and all of our movements look much smoother, much better. But you'll notice if I do the forward and right or forward and left, it doesn't look super clean just because of the types of animations that we're using. So again, if I had an animator on my team, this would be a great little exercise to use that for. But I don't, so we're using free Mixamo assets, and this is the best we're going to get. Okay, so our arm state is actually working pretty good. I can rotate the character, and he moves where I want him to move. I can move backwards, still keep rotation. If I, kick and I punch, all of that happens really nicely. I'm going to get rid of that timer in the top left-hand corner because it's kind of annoying me. I don't want to keep flipping between the states. So to do that, in our player character attack end is where we trigger our logic for the timer. And I'm just going to comment that out for now. And let's recompile. And then we'll go ahead and start cleaning up our running mechanics. Okay, so going back to our walking mechanics, you'll notice that when we first start the game, and we, let's say, punch, he is rotating the way we want him rotated, but he's moving way too fast. And that is because we're only controlling the arm state through pressing the R button. And that puts everything back in normal. But when we fire the attack move, it doesn't actually arm our character properly. So what we're going to do is we're going to go back to our code, and you'll notice this is kind of all we're doing in our attack start. We're setting the collision profiles, but we're not really quote-unquote arming the player. So we're going to make a call to arm player, and we're going to say true. And that should fix that initial sliding around. So let's recompile and take a look. Alright, all recompiled. Let's go back. And now when I punch, hey, we're back to what we are expecting, which is a nice slow move that lets us, get into some fisticuffs with future enemies. Alright, let's get out of arm, let's run around. Jumping is good, jumping and punching is still good. It drops us into the arm mode immediately, which is kind of cool. But what about crouch? So crouch is doing okay, but again, you see our movement is kind of screwy. It's a little too fast, or the animations are too slow. So let's go back to our crouch locomotion state and see what's happening here. So our movement is happening at 300. Our crouch, going back here, our crouch walk speed is 200. So obviously we are never hitting the topmost part of the animation. So let's just lower this down a bit. Maybe even say 150. And now when we crouch, okay, that looks much better. Now what about punching and crouching? So we punch, we move around, we stand up, and it's all kind of good. Now, you can add in a little bit of extra logic that basically says, hey, if I'm armed and I'm crouched, I still move a little bit slower than I normally would. And this is primarily just preparation for when we have weapons and sort of heavy things that we're going to be carrying. But this is looking actually not too bad. So we got punching, we're able to flip between states, or crouching still works. Oh, but there's a bug. So check this out. If we're crouched and we press shift, I'm not running, but then when I release crouch, right, he immediately kind of goes back into running mode. And that is because we're not really adjusting the movement based on our crouch state. So let's go ahead and clean that up. Going back to our player character, we're going to look for a crouch start. And right here, what we're going to do is just add a little bit of logic that handles our movement speeds based on this state. So if I am armed, I'm going to basically say get character movement. We're going to set our use controller desired rotation to false. And we're going to set our orient rotation to movement to true. We are then also going to say get character movement max, where is crouch? Maximum crouch speed equals our max crouch speed. Otherwise, we are going to just say max, get character movement max walk speed equals our oops, max walk speed equals our max walk speed crouch equals our max crouch speed. Oh, sorry, this should have been max armed speed. So if we're armed, handle our rotations of our player and our controllers, set it to the arm speed. If we are just crouching without doing anything else, just limit the movement to our value. And on crouch end, we're going to do just another little flip. So if I am armed, but I'm not crouching, control desired rotation is going to be true, and get character movement, be use control desired rotation, oops, orient rotation to movement equals false. And then we can also be a little bit clever and set our walk speed to our arm speed. So similar to this one, but it's going to be for our walk speed. Otherwise, if B is running, then we set our character movement to our run speed. Otherwise, we just set it to our walk speed. All right, let's recompile and give that a shot. Okay, so we're all recompiled. Let's go back to our project and now load this guy up. So we punch, we walk, we rotate, we kick, we're still all good. Our walking is in place. Now you'll notice it's a little jarring with this animation. It kind of snaps a little. That's just the animation. It's really nothing to do with our blend spaces. But there's our run, there's our walk, there's our crouch. And you'll notice now if I'm holding down shift and I get rid of my crouch, he's going back to a proper walking mode. And now if we're also crouched and we punch, we correctly adjust the states as expected. So there you go, guys. We have now a character that's a little bit more robust. We have this cool arm state that is going to be quite helpful for when we lock onto our targets. And as usual, everything else should still work. There's our combos, there's our physics, sound effects, all that good stuff. But now with the added benefit of running, walking, and some helpful little crouch states. Cool. Thank you for tuning in, and I hope to see you guys next time.